Good morning. This is our topic for the fourth quarter, which is trigonometric functions, which involves SOHCAHTOA. Okay, at the end of these slides, the learners will be able to illustrate the six trigonometric functions such as sine, cosine, tangent, secant, cosecant, equotangent. For this fourth quarter, we're going to have the six trigonometric ratios, such as we have the trigonometric ratios involving special angles. So in here, we're going to have the angles of elevation and angles of depression, such as we are going to have as well the use of trigonometric ratios in solving real-life problems involving right angles, right triangles, rather. The other one that we're going to have is the oblique triangles, such as we're going to have the law of sine and its application, plus the law of cosines and its application. So what are the trigonometric function upon investigation is the sine function. So the first one that we're going to have, we must have the right angle. Opposite the right angle, that side is the what you call the hypotenuse, which is the longest side. And then we're going to have the like opposite of the angle A, which is this is the side A. And then we have the adjacent side of angle A, which is side B. For us to get the sine of angle A, it is said to be that sine A is equal to the length of the side of the opposite to angle A over the length of the hypotenuse. Two other important trigonometric functions associated with right triangles are cosine function and tangent function. For us to get the cosine of angle A, we're going to have the length of the side of adjacent to angle A over divided by the length of the hypotenuse. And then for us to get the tangent, so we're going to have the length of the side opposite to the angle A over the length of the side of the adjacent to angle A. Okay, so in here, no, we're going to have the symbols is used to indicate that the triangle is a right triangle. Again, what are the parts of the right triangle? So we have the opposite side, no, the reference angle, which is the theta, and then we're going to have the hypotenuse, which is the opposite side of the right angle. So triangle ABC is a right triangle with angle B as its right angle. So this is the right angle. Angle C as its reference angle. The hypotenuse is line segment AC. And then line segment AB is the opposite side, and line segment PC is the adjacent side. So what are the reference angle? This is the acute angle between the terminal side and the x-axis. It is always positive. It is indicated by the symbol theta. So angle C is the reference angle in triangle ABC. Theta. Okay, so opposite side is the side across the reference angle in the right triangle. So line segment AP is the opposite side of angle C. The adjacent side, which is the side next to the reference angle in the right triangle. So line segment BC is the adjacent side of triangle ABC. The hypotenuse is the longest side of the triangle and is always opposite to 90-degree angle in a right triangle. So in triangle ABC, the hypotenuse is line segment AC. So this is the hypotenuse. Again, this is the hypotenuse. This is your reference angle, which is theta. This is the adjacent angle, adjacent side, and this one is the opposite side. Okay, for the first example, we have in here triangle ABC. So we need to find the trigonometric function values of angle A. So angle A is our reference angle. So for us to have the reference angle, so the opposite side that we have is the line segment BC, and our adjacent side is line segment AC. So for us to have the SOHCAHTOA, so for the sine A, no, so we're going to have 9 over 41. And Ka for the adjacent over the hypotenuse, so that is 40 over 41. And then for our tangent, which is TOA, tangent A is equal to 9 over 40. If and only if the given is said we can have the lowest term, we can convert now or extract the lowest term. But in this case, this is already the lowest term. Let's have number two, which is we have as well triangle ABC to find the trigonometric functions as well. So we're going to have put in our mind that we're going to use SOHCAHTOA. For us to have the angle A is our reference angle. So the opposite side that we have is the line segment BC, and our adjacent side is line segment AC. So opposite over hypotenuse. So our hypotenuse is 13 and our opposite is 12. So 12 over 13. Ka, which is adjacent over hypotenuse. So wherein we have 5 as our adjacent side and 13 as our hypotenuse. The last one is TOA, which is tangent A. So we're going to have their opposite over adjacent, which will give you 12 over 5. To wrap up, no, so we have the sine, cosine, and tangent. Again, these are the parts of the triangle, the right triangle. We have the hypotenuse, okay? We need to find out which is the reference angle. In this example, our reference angle is angle A. So our adjacent is line segment AC, and our opposite is line segment BC. For us to get the sine, which will give you opposite over hypotenuse, so that is A over C. For us to get the ka or the cosine, so that is adjacent over hypotenuse, and that is B over C. And for the TOA, which will give you opposite over adjacent, so that is A over B. So in here, it said to be, we have three triangles. So this is how are you going to have the SOHCAHTOA. Okay, so you just need to have the reference now at the top, and that below will be the table of measurement. So in here, there's another example, no? So the reference angles, triangles will be at the top, and the bottom will be the measures. Okay, this one, no, so it's said to be SOHCAHTOA, which is the mnemonic used for remembering the equations. So, which will give you opposite over hypotenuse, ka, adjacent over hypotenuse, TOA, opposite divided by adjacent. So, for the cosecant, which is the opposite of sine, so hypotenuse over opposite, and then secant, hypotenuse over adjacent, cotangent, adjacent over opposite. Okay? So this how are you going to have the following. This one is the activity number 1. So kindly have and then express your answer in lowest term. This is the second part of activity 1. Okay? Kindly show your answer, then box your final answer.